Okay, in this short video, I'm going to try to explain to you my behavioural economics on a post-it number 2. This is the Ellsberg, or what's known as the Ellsberg, or a version of the Ellsberg paradox. It gets its name from its creator. The person that first presented the Ellsberg paradox was called Daniel Ellsberg. Decision theorists who later became much more famous for other things to do with the Vietnam War, but if you're interested in that, I'll let you Google his name, Daniel Ellsberg. He presented the Ellsberg paradox first. I think it was in around the early 1960s that he first published this work on the Ellsberg paradox. Okay, so the basic version that I'm presenting here to you, imagine that you've got a bag. You can't see inside the bag, but you know that the bag contains 90 balls. And you know that of those 90 balls, you know that 30 of them are definitely black balls, 30 of the 90 balls. And you know that the other 60 are either red or blue, of an unspecified mix. So they could all of those 60 balls could be red, all of those 60 balls could be blue, or any sort of mixture of red and blue. Could be contained within the bag. You don't know that. All you know is that 60 of them are either red or blue. And then you're asked to pick a ball from the bag. You can't see inside the bag. You just put your hand in and you pick out a ball, right? So just ignore this bottom decisions for the moment, or options at the moment. And imagine that you're asked to choose between A or B here, right? Now, if you choose A and you get a black ball, if you pick out a black ball, you'll win £500. But if you pick out a red or a blue ball, you won't win anything at all. That's what A says there, right? So because you know that 30 of the 90 balls are black, essentially you know that you've got a sort of definite 1/3 chance of winning £500. If you go for B, you won't get anything for a black ball or anything for a blue ball, but if you were to pick a red ball, you would win £500. Now, you know that there might not be any red balls. There could be 60 red balls, or any number of red balls between those two numbers. So really, that's your chances of winning are what's known as ambiguous or uncertain. It could be that you have no chance of getting £500 if there's no red balls. There could be a 2/3 chance of getting the £500 if all the balls, all those 60 balls were red. So it could be anywhere between those sort of probabilities, 0 to 2/3 chance, sort of ambiguous, right? Now, what Ellsberg speculated is that most people would, in the instance when they were asked to choose between A and B, they'd go for A, right, rather than B. They'd rather have the certainty of a 1/3 chance, if you like, rather than the ambiguity of anything between a 0 and a 2/3 chance, right? Now imagine C or D instead of A or B. So the person's asked to choose between C or D. If they choose C and they pick either a black ball or a blue ball, they'll win the £500, but they won't get anything if they pick a red ball, right? If they go for D, they'll get the £500 if they get a blue or a red ball, but they'll get nothing if they get a black ball. Now, you can see here that because there could be anywhere between no blue balls and 60 blue balls, then the chances of winning £500 if you go for option C are anything between 1/3 chance, because you know there's a definite 1/3 chance if you get a black ball, and there might not be any blue balls. But if there were 60 blue balls, it would be a certainty of getting the £500, right? So it could be anything between those probabilities of a 1/3 chance or a certainty. It's ambiguous again, a bit like B. But if you went for D, you know that 60 of the balls will be red or blue. So you know that there'll be a 2/3 chance of you getting the £500 if you were to pick D. So in this instance, D has the certainty of a 2/3 chance, if you like, of getting the £500, and C is sort of an ambiguous chance of anything between a 1/3 and the certainty, or 1/3 and a probability of 1, a definitely getting the £500, right? Now, what Ellsberg predicted is that most people would choose D in the choice between C and D. And you can imagine yourselves what you would choose in those instances, right? So what Ellsberg predicted is that in the choice between A and B, people will tend to go for A, and in the choice between C and D, people will tend to go for D. Okay. Now, if you think back to behavioural economics on a post-it number 1, the Allais paradox, we talked about independence, didn't we? And that is the assumption that, or implied from independence, is that any common outcome between two options would be considered to be irrelevant by the individual when making their choices. So if you were to think about A and B again, you can say that if they get a blue ball, they'll win nothing if they pick out a blue ball in both cases. So really, according to the independence axiom, or what's sometimes called the sure thing principle in this context, people should consider that little bit there to be irrelevant in their decision between A and B. If you look between C and D, you can see that again, if they pick a blue ball, there's a common outcome, £500 in this case. So that should be considered to be irrelevant. According to standard economic theory or standard rational choice theory, picking the blue ball will be irrelevant, and they'll base their choices on the other attributes of the options. So if you can see that in both instances, if picking the blue ball is irrelevant, you can see there that A is identical to C, isn't it? £500 if you get a black ball, nothing if you get a red ball. And B is identical to D, right? £500 if you get the red ball, nothing if you get the black ball, right? So what that means, according to standard economic theory or the sure thing principle, is that if people choose A, they really should always choose C. And if they choose B, or if they choose B, they should always choose D. Or they should consider those A and B to be equally preferable and C and D to be equally preferable, right? Now, that Ellsberg predicted that people would therefore go for A and D. You can see that anybody that would do that would, strictly speaking, be economically irrational according to standard rational choice theory. Right? Now, Ellsberg originally ran his experiment just on guess at a dinner party and published his results on the basis of that, I think. But the observation of the Ellsberg paradox, or the observation of what Ellsberg predicted, has held up reasonably strongly, I think, in studies that have been undertaken ever since he published his paper back in the early 1960s. So we talked about ambiguity, didn't we, and uncertainty, and all what I've said here is that what probably explains this result is people tend to be ambiguity averse or uncertainty averse. That is to say that they're willing to pay a premium in order to avoid the ambiguity that's present in B, anything between a 0 and a 2/3 chance of getting the £500, and they're willing to pay a premium in order to avoid the ambiguity embedded in C, right? So the ambiguity in B directs people's preferences towards them choosing A in the choice between A and B, and the ambiguity in C sort of prompts many people to prefer D rather than C. So that might be the reason, that's probably the reason that explains the Ellsberg paradox. Now, again, there may be very good evolutionary reasons for why people prefer to avoid ambiguity or are willing to pay a premium to avoid ambiguity if they're given the chance to do so. So the fact that people do demonstrate what Ellsberg predicted often, may not really be a fundamental mistake in their decision-making necessarily. It could be caused by a phenomena that's kind of helped us to survive as a species. Okay, I'll finish at that point. That's the Ellsberg paradox. I'll post behavioural economics on a post-it number 3 quite soon.